Hello, hi everyone. Welcome to Advanced Mathematics Review class. And today we are going to solve a question on linear programming. Our question has two parts. The first part of our question is Catherine makes two types of garments, trouser and shirt. Trouser requires 2.5 meter of material, while a shirt requires 2 meter of the material. The business uses up to 400 meter of the material daily for production of the two garments, but they produces at most 80 meter of trousers and at least 60 meter of the trousers. Letting X representing the number of trousers made and Y represent the number of shirts produced daily. The question is, write all the inequalities satisfying the given information. Here we are, Catherine produces two types of garment. There is a trouser, and there is a shirt. Each of one requires the material that requires material. The question says a trouser requires 2.5 of the material. So a trouser requires 2.5. The materials are measured in meters. 2.5 meters of the material, while a shirt requires 2 meters of the material. And the total available materials is 400 meters. That is the total available materials. And so letting X as X representing the number, so let X represent the number of trousers made, and Y represent the number of shirts made by Catherine. So because we know each trouser requires 2.5 meter and each shirt requires 2 meter of the material, but the total available material is 400 meters, so we have 2.5. We create inequalities as follows. So I can write these inequalities that satisfies the given conditions. So the first inequality is each trouser requires 2.5 meter of the material, but the number of trousers made by Catherine is X, so we just take 2.5 times X plus each shirt requires 2 meter of the material, but the number of shirts made by Catherine is Y, so just take 2 times Y. But the total available material is 400 meters, so the total production should be less or equal to that amount, because he has only 400 meters, so she's supposed to use only 400 meters or less than that for the daily production. Again, we are given further information from the question that the business uses up to 400 meters for daily production of the garment, but produces at most 80 meters of the trousers. The business produces at most 80 meters of trousers. And because in our question we have each trousers requires 2.5 meters, so this inequality is just 2.5 meters times the number of trousers, which is X. At most means the maximum value, so this should be less or equal to 80 meter. So this is, we can call it this a first inequality, and this our second inequality. The way that at most in linear programming means that that is the maximum number, maximum unit of the material required for production. So that's why we use inequality less or equal to. Again, she produces at least 60 meter of the shirt daily. So there is also at least 60 meters of shed daily. At least means just the minimum amount, so the inequality will be, and because each shed requires 2 meters, so we just take 2 times the number of shed, which is y. This should be greater or equal to 60. We use greater or equal to because the word at least in linear programming means the least amount or the minimum value that can be used. So that's why it's greater or equal to. This is inequality number 3. Again, because in production we don't need the negative values, so we use non-negativity constraint or non-negativity inequalities, non-negativity inequalities, and these are x, which is the number of trousers, is supposed to be positive, greater or equal to 0, and y should be also greater or equal to 0. Of course, these are inequalities that satisfy the given information. Then, after creating all the inequalities, the question, the second part of part A is find the number of each garment, that is trousers and shirt, made to produce the maximum income if the income for income is given by this function. So we are given the objective function in this case, the objective function. This is just a function of x comma y. X represents trousers made and y represents shirt. This is equal to 300x plus 200y. We need the maximum income, so we need the maximum value of this this function. Now, how do you get this the maximum value of this function? The maximum value of the function can be obtained by first sketching the graph of this inequality, and then finding the feasible region, the region which satisfies all the given inequality. After then, we identify the corner points. After the corner point, substituting the corner point to this objective function, we can identify what is the maximum daily income. Now, we come to sketching the graph of inequality. We have our first inequality is 2.5 plus 2y. We first construct the tables of values. We represent, we just replace inequality by equal sign in order to construct the table of values. So this is 400. We just constructed a simple table by using x and y intercepts. So this is x, y. When x is 0 and when y is 0, we find the corresponding missing values. So when x is 0, we find the corresponding value of y. When x is 0, we put here x, this is 2.5x. When x is 0, this term is 0. So we have 2y equals to 400. Dividing by 2 both sides, we get y equals to 200. And again, when y is 0, we put it y here. 2 times 0 is 0, so this term cancel. Remain 2.5x equals to 400. Then we divide by 2.5 both sides. Divide by 2.5 and see. Because here we have decimal, we can just remove the decimal. Multiplying by 10 through. So we get this is 4,000. Divide by 25. So we can divide 40, divide by 25, it's 1. 25 times 1 is 25. Taking away from 40, we get 15. Then 40, take away 25 is 15. Shifting, dropping 0, we get 150. Then divide by 25, it will be 6. 6 times 25, we get 150. This goes. Remaining 0, we just drop it there. So 2.5 divided by 400 divided by 2.5 is for sure 160. That is the graph for the table for the first inequality. our second inequality is 2.5x. This is less or equal to 80. And in the case of drawing, just replace the inequality sign by equal sign. So just divide by 2.5, divide by 2.5, we get x equals to, we remove the decimal decimal point first by just multiplying by 10, because we have one decimal point, multiply by 10, so this will be 800 divided by 25. 80 divided by 25, 3 times 25, 75, remains 5, will be 50. 50 divided by 25 is 2, so x equals to 32. And again, the last inequality is 2y equals to 60. Divide by 2, divide by 2, we get y equals to 30. So after getting all the tables, all the values that we need to sketch the graph, we just sketch our graph like this. Okay, so sketching the graph is just a sketch of the graph. So I can just sketch like this. The first we label the axis. This is x-axis and this is y-axis. And then because I'm just sketching, I can just check what are the values of x. The values of x is 106 and the next one is 32. So I can just put maybe here 32. And then after some interval 160, because of course we need to use a scale in order to reach the values, and I just use this kind of method because I'm just sketching I just want to see the nature of this graph. And the values of y here, the maximum one is 200 and the other one is 30, so I can just go, maybe this is 30, just put it here, and up here somewhere 20. And the negative values are not needed in linear programming because we have there is no negative number of trousers and no negative number of shades, so the negative part of the xy planes are not needed. So we don't need, of course, shade, because all that we need is the positive values. That's why the negative part of y is not included in this graph, and the negative part of x is not included. We just need the first quadrant of the xy plane. Okay, now our first point is x is 0, y is 200. X is 0, y 200. We have x is 0, y 200 is this point. And the next one is 160x and y 0. 160 is this point. Just use your ruler to join the point. Join the point like this, and then we write the equation connecting these two lines. The equation was 2.5x plus 2y equals to 400. That is our first equation. But of course, this comes from the inequality. Our original inequality that result to this equation was 2.5x plus 2y less or equal to 400. So we need to check, because this line now divide the xy plane into two halves. There is lower half and the upper half. We need to check which half satisfy this inequality. This is easy. We can just do by just choosing any point on the lower half and the other point on the upper half. On the lower half is simple. I can just use the origin. The origin is 0, 0. If I put x is 0, y is 0, I can find that 0 plus 0 is 0, which is for sure less or equal to 400. So I can see that the lower part satisfies the given inequality, which means that the upper part will not satisfy the given inequality. So in linear programming, normally we shade the parts which do not satisfy the given inequality. So that is the first one. The second one is the line x equals to 32. The line x equals to 32 is just a vertical line passing at 32. This is just the line x equals to 32. And again, the original inequality was 2.5x. This is less or equal to 8. So of course we need to check which part of this inequality of this line, because we have now this left part and the right part of this line, x equals to 32. We need to check which part for sure satisfy this inequality. This is also done simply by just choosing a point here and a point on the right of the line x equals to 32. So if we check the point, any point on beyond 32, and if we multiply by 25, we are getting a number which is bigger than 80. But if we check take a point which is below 32, maybe 0 or 10, and then multiply by 2.5, we are getting number which is less than 80. That means this part will satisfy the inequality, and this part, the other part, will not satisfy the inequality. And normally, because we are shading the part which does not satisfy the given inequality, that's why I just shaded the right part of the line x equals to 32. And the last inequality is, the equation is y equals to 30. So you just draw the line which is passing at y equals to 30. Just draw like this. This is our line, y equals to 30. And this line comes from the inequality. The original inequality was y greater or equal to 60. And of course, if you simplify this, it's just the same as y greater or equal to 30. Dividing by positive number both sides does not change the sign of inequality. So this is y greater or equal to 30. Checking from our graph, we have the two parts, the upper part and the lower part of this line y equals to 30. So the, for sure, above this line satisfy the inequality that y is greater or equal to 30, but below this does not satisfy. So we just shade the lower part of this inequality. So there is a region which remains unshaded. Looking clearly, this is the region which remains unshaded, and this is what we call the feasible region. And what is the feasible region? The feasible region is just the region where taking any point in this region will satisfy all the inequality under consideration, which means any point in this region will satisfy all these three inequalities. Okay, now if that's the case, the point of interest here in the feasible region, we just need to check the corner point of this feasible region. So we have this corner point, this and this one. We can just name them. Maybe this is corner point A, this is corner point B, C, and D. So we need to read what are the coordinates of this corner point, and then after getting the corner point of the feasible region, we just substitute into the objective function, which is this one, to get the maximum income, maximum daily income. And from there we can state what are the number of trousers made and number of shirts made daily. Okay. Now, from our sketch graph of this inequality, we can just read the corner points. So I can just write the corner point. The corner points are, we have the first point, which is corner point A. In our case, I just labeled it as A. One can use any other notation. You can use any other letters to name this point. But in my case, I just decide to use A, B, C, D to name this corner point. So the corner point A, sure, this corner point A, the value of x is 0 and y is 30. So we can just read the corner point A is 0, 30. And the corner point B, coming to this line, first we read the value of x, which is now here is 32, and the value of y is 30. So the corner point B is 32, 30. And the next corner point is corner point C. Corner point C, the value of x is clear, is 32, but what is the value, exactly the value of y? One cannot see clearly what is the value of y, but the value of x is 32. Now to get the value of y, because the corner point C is just the intersection between the line x equals to 32 and y, and this line, which is 2.5x plus 2y equals to 400. So you can just solve the two equations simultaneously. That is 2.5x plus 2y equals to 400, and x is 32. So if we know the value of x, we can just make direct substitution. That is 2.5 times x, which is 32, plus 2y equals to 400. So taking 2.5 times 32, I can just use my calculator here. I have 2.5 times 32. The answer is 80. So I get 80 plus 2y equals to 400. So taking 80 on this side, we have now 2y equals to 400 minus 80. So 2y will be equals to 320. To get the y, we just divide by 2 throughout. So y will be equals to 160. So the corner point C is 32,160. So that is the technique which is used to identify the corner point which cannot be read directly from the graph. Because we are here, we know the value of x, but the value of y is not seen clearly. But if one uses the graph paper, you can see directly from your graph paper the values of each corner point. Okay, now the last corner point is corner point D, which has the coordinate. The corner point D is this point. The value of x here is 0, and the value of y is 200. So I can just put it 0, 200. These are the corner points which can help us to get the maximum daily income. Now, the last step of this question is to substitute. So we substitute each corner point into the objective function. The objective function is just a function which tells us whether we can get the maximum value of the daily income, in this our case, or in other question is just a function which can help us to get the minimum cost or minimum daily production, whatever. But in our case, we need the maximum daily income. So we can just draw a table-like form like this, put the column of corner point, and put the objective function, which is f of x comma y equals to 300x plus 200y, which is the given objective function. And of course, we need the value of each objective function at each corner point. So what we do, we just take the first corner point, which is point 0, 30, means that here x is 0 and y is 30. Substituting here, so we have f of now 0, 30, because our x is 30 and our x is 0 and our y is 30. So substituting this into the objective function, we'll get 300 times x, which is 0, plus 200 times y, which is 30. So multiplying there, we get multiplying here, 300 times 0 is 0, 200 times 30, 2 times 3 is 6. We have 3 zeros, so put 6,000. And B, corner point B is 32, 30. Which is now f of 32, 30, which is equal to 300 times 32 plus 200 times 30. So this is the second corner point. You just multiply here. 3 times 2 is 6. 3 times 3 is 9. We have 3 zeros, plus 2 times 3 is 6. We have 3 zeros. So we have 9,600 plus 6,000. Adding here, we get 15,600. That is the value of the corner point B at this value. Again, we have the corner point C, which is 32,160. Just substituting the objective function to get its value. So this will be f of 32,160 equals to 300 times 32 plus 200 times 160. Multiplying here, one can just use the calculator, which is allowed. 3 times 32 is 96. We have 3 zeros, plus 2 times 16 is 32. We have 3 zeros. Then adding here, 32, 3 zeros. Adding here, we'll get, this is now 0, 0, 6, 9. Adding here, we'll get 0, 0, 6, 11, 4. So here you get 4,600,000. And lastly, we have the corner point D. The corner point D, which is 0,200. Corner point D, which is 0,200, which means x is 0 and y is 200. So this will be f of 0,200 equals to 300 times x, which is 0, plus 200 times y, which is 200. So multiplying here, you get 300 times 0 is 0. 200 times 200 is 4, with 4 zeros. This is 40,000 now. These are Tanzanian shillings, of course. The values are in Tanzanian shillings. I can just write that. So we are done by substituting each corner point in the objective function. Now remains just to conclude the question by just answering what is required. The question requires us to state what is the maximum daily income for this. Find the number of each types of garment the business can make in order to get the maximum daily income. Now from these values which are obtained from the corner point, we can just take what is the maximum value here. This is 6,000, 15 is 41, this is 40, and for sure this is the maximum value. The maximum value is obtained at the corner point C, where x is 32 and y is 160. This means what? This means that the corner point, and in our case the corner point C with 32,160 is the optimal point. The optimal point is just a point which gives us what we need, the point that help us to answer the required question. Of course, in our case, we can just say this is the maximum point, and from which the maximum daily income is the maximum daily income is, we can just read here, is 41600 Tanzanian shillings, of which each garments which are made here, the trousers are 32 and shirts are 106, of which 32 trousers and 106 t-shirt must be made. So in order to get the maximum daily income, Catherine is supposed to manufacture, to make 32 trousers and 160 shirts to get the maximum income daily, which is 41,600 Tanzanian shillings. Okay, so that is our first question, part A, which is linear programming. Of course, this kind of linear programming is just a normal linear programming that we had even in O level. Now let's see the second part, and this part is the transportation problem, the problem or the linear programming that deals with the transportation of the resources from one center to the other center at a minimal point of at a minimal cost. So the question is, a Chinese wheat flour company has two factories, A and B. So there are two factories. The rice factory A, you can just label as this, and there is another factory B. These are the Chinese wheat flour company has two factories which supplies warehouses at C and D. So each of these flour is being transported to other parts. These are warehouses. You can just exchange the notation. Maybe these are A and B in order to just simplify. So these are the warehouses. Then warehouses here are labeled as C and D, which means the wheat flour is transported from A to C and from A to D and from B to D and from B to C. Now the question is, in order to maximize the cost of transportation, which part or which route is most preferred in order to minimize the cost? Now, the weekly factory capacities are given as 160 and 140 units respectively. Means this has 160 units and this has 140 units respectively. These are the capacities of the factories. And the warehouses requirement are 70 and 120, which means warehouse C requires 70 units and this requires 120 units. And the cost of transportation from each unit, for 1 unit of flour from A to C, the cost of transportation from A to C is Tanzanian shillings 160. This is just a 1 unit of a flour, and from A to D is Tanzanian shillings. This is Tanzanian shillings 240. What about similar? The cost of transportation from B to C is 200. B to C is Tanzanian shillings 200, and from B to D is 260 Tanzanian shillings. Okay. The question is, find all the inequalities associated with the problem and the objective function of this problem. So we need to find all the inequalities which are associated with this problem, and then we need to find the objective function. Now, because this is just a weighted problem, we can just transform it to algebraic problem by just representing each of the unit by variables. So we can just, let's say, x to be the unit transported from A to C, and y be the unit, just be the unit from A to B, which means the unit transported from A to B, just call it x, sorry, this is x, and the unit from A to D, just call it by y. That's just notation. And because D requires 120 units, so D requires 120 units minus y from B, which means B has already get y from A, so the remaining units will be obtained from B, which is now 120 minus y. And because from A to C is x, then from B to C will be the total requirement here is 140. Oh, it is 70, so this would be 70 minus y. Okay. Of course, since there is no negative unit that is transported, each variable x and y are supposed to be positive, so the inequalities, x is supposed to be positive, so x is greater or equal to 0 and y is greater or equal to 0. That means there is no negative units which are transported from either factory to any warehouse. So if that's the case, x, which is the unit transported from this one, should be less or equal to 70, which means x should be less or equal to 70, which means this x, which is the unit transported from A to C, should not exceed 70, and y also should not exceed the total unit which is required here, which is 120. Okay, now if that's the case, if we add the two, x plus y should not exceed the unit which are taken from factory A, should be less or equal to the total requirement of the factory 160. You can call it, this is equation number 1, because we are taking the wheat flour from A, x is taken from A to C, and the y is taken from A to D. So if we add the two, should not exceed the capacity of the factory. That's why we use less or equal to. And of course, if you take the unit that are transported from B to C and from B to D, should not exceed the factory capacity, which is 140. That is, if you take 70 minus y plus 120 minus y, of course, y, this is supposed to be x, because the unit which is taken from A to C is x, so that is 70 minus x. This should not exceed 140. So simplifying, we'll get negative x minus y plus 70 plus 120 is 190, less or equal to 140. So negative x minus y equals to, taking this, it will be 140 minus 190, and that is negative. This will be less or equal to negative 50. And of course, this is negative x minus plus y now less or equal to negative 50. Dividing by negative 1 throughout. Dividing by negative 1, the sign of inequality changes. Dividing by negative number, always the sign of inequality changes. So now we have x plus y should be greater or equal to 50. This is inequality number 2. Inequality number 2. So together with this inequality, or these are the inequalities that can be obtained from this particular problem. Now remain the objective function. The objective function normally is obtained by the objective function. This is a function of x comma y. The function is obtained by from the transportation cost from each factory to each warehouse. So you just take the unit which is transported from A to C is x, and the cost is 160. So you just take, this will be 106 times the unit which is x, which is taken from A to C, plus the unit which is taken from A to D is y, and the cost is 240. So you just take 240 times y, plus the unit which is taken from B to C is 70 minus x, and the cost is 200. So you just take 200, which is the cost of each unit, times the unit taken, which is 70 minus x. And of course, plus the unit which is taken from B to D, which is 120 minus y, the cost is 260. So just take 260 times the unit taken is 120 minus y. So after just simplifying, we get the required objective function. So this will be equals to 160 x plus 240 y plus 200 times 72 times 4 is 14. We have 0, 3, and minus 200 x 26 times 12, I can just use my calculator here. It is 260 times 12, so you can just take 26 times 12, and this is 312, so you get plus 312. You have 2 zeros, minus 260y. So what remains here is just simplification, collecting the like terms together. So we have the terms with x is 160 and 200 x. So taking away this is negative, this is positive, we remain with negative 40x. 240 minus 260, we remain with negative 20y, plus 140, that is 10400, adding 00213. Adding together here, I'll get 00623. So we have 32,600. 600. And this is for sure the objective function, which is f of x comma y equals to negative 40x minus 20y plus 32,600. This is the objective function, and here the aim of this transportation problem is to minimize the cost. So we need to minimize the cost. We need to minimize the cost of transportation. That is the aim of this transportation problem. So for sure we can just summarize the information by writing a linear programming problem now for this transportation problem as okay. Now the linear programming problem now. Now becomes, of course, that is what we need to do. The linear programming problems now becomes minimize the objective function, which is f of x comma y equals to, we have obtained is negative 40x minus 20y plus 32,600. 32,600 subject to the constraint. We have the constraint x less or equal to 70, y less or equal to 120, x plus y less or equal to 160, and the last inequality is x plus y greater or equal to 50, together with non-negativity constraint, which is x greater or equal to y. All of these are called inequalities. And this is called the objective function. Now we can of course find the maximum, the minimum cost for this transportation after just following those steps as we did in the first part of this question. We can just sketch the graph of this inequality, identify the corner point, and lastly see what is the minimum transportation cost. Okay, and that marks the end. Thank you very much.